Hi, I'm Kelly Carter, and this is my reassessment for Chapter 21. The question asks us to find the magnetic field right when the loop of wire is outside of the magnetic field region and right after it leaves the magnetic field region. When this occurs, the loop of wire does not experience a magnetic field. Therefore, we have no current, nor do we have a magnetic force. And also, the charges are distributed evenly throughout the loop of wire. Right after the loop of wire enters the magnetic field and right before it exits, we do experience a current and a magnetic force. The loop of wire the magnetic field is exerted partially on the loop of wire, and since it has a magnetic field and also a constant velocity, that lets us know we have a uniform electric field. If we have a uniform electric field, we can find the change in potential by integrating over the dot product of the electric field and the length, which will give us the velocity times the magnetic field times the height. Now that we have the change in potential, we can use the definition of resistance to find the current. So the current will be the change in potential divided by the resistance in the wire. Using Faraday's law, we can now find the magnetic force. This equation was derived from Faraday's law, so our magnetic force would be the cross product of the magnetic field and the product of the current times the height. And being that our magnetic force is pointed in the negative y direction, the distribution of charges will be our negatives on the top and our positives on the bottom in the loop of wire. Okay, and now we have to find the current and the magnetic force when the loop of wire is completely inside of the magnetic field region. When this occurs, according to Lenz's law, we do not have a current because the induced EMF cancels. If you look at both sides of the H would be parallel to one another, and therefore, since they are parallel to one another, they oppose each other and they cancel out, which will give us a net magnetic force of 0. Thank you.